Hey, how's it going, guys? Today I want to go through a real Google phone interview coding question. Let's walk through a little bit about this problem set. So we are given some relationship, a hierarchical relationship between some parents and some children. So let's say we have so for example, the first relationship is the animal, and then the child. I mean, the parent is animal, child is mammal. Second relationship is the parent is the animal, child is bird. The third relationship is the parent is a life form, child is mammal. Primary child is the animal, and then the next one, the parent is cat, child is lion. Next one, the parent is mammal, child is cat. And the last one, the parent is animal and child is fish. And then we put all this relationship into this relationships list. So as we can see, this is a class relationship, and it has two attributes. One is the parent, another one is the child. And then as soon as we have these two components, we can describe the entire relationship, and then we have all the relationship bundled together, and then get fed into this relationships list. And so the problem for the phone interview, for Google phone interview, is given we have all these relationships, we want to print out the hierarchical relationship in this form, right? So the parent of all the child, which has no parent, so because this the highest parent, and then it will print it has the smallest amount of space. It looks like this. So life form is the parent of animal, and life form itself have no parent. So the gap is the smallest, as we can see. And then the child and one and only child for life form is animal, which is created by this relationship and has two spaces, two tabs. And then animal has three children. One's mammal, bird, and another one's fish. So we can see animal has mammal, animal has bird, and also animal has fish. So because they are in the same level, so the amount of space, amount of tab is the same for mammal, for bird, and also for fish. And then cat is a child of mammal, and lion is a child for cat. That's why they are lower in the hierarchical order, and then they have more spacing. So the Google phone interview question is to write a function to print it out the relationship like this. So feel free to pause the video and then try it yourself, and then I can show you my solution. So yes, this is my solution. So first, this looks like a depth first search problem, and then we can create a dictionary that recording all the relationships. We have a parent to children, so the keys are the parent, and then the values are a set of children. So it's a dictionary, the key, all the keys are the parent, and also the values are it's a set of children. And then we have another dictionary. It's called children to parent. So the key are the children, and then the value are the parents, the parents to the kid. So we have the two directional. One is from the parents to children, and the value are the set. And then we have another one go the other way, the other direction. So for all the relationship in the relationships, and then we are mapping for the parents to children, which is this dictionary, and then the keys are the parents, the parents component, the parents attribute of the relationship, and then we get to the set because this is the set, and then we can add the child. So basically, we are collecting all the children that belongs to the parents, and then we have the dictionary for it. And then the other ones, it goes the other way around, and with the key is the child, and then the value is the parent. So we have another for loop that is searching for the main root, which has no parents, because it's the root that generates all the subsequent children. So how can we do this? So the main root has no parents, and then we can use that as a component, I mean, as a key to help us to find the main root. So we first look at all the children, and this is where we can get all the children, because the key is listing all the children. And if we are looping through all the relationship and then look back to the researching for the parents, or the parent, if the parent has no if that parent is not a children to any let me say again. So if that parent is not children to any of the relationship, and that would be the main root. And then we can find that. So we keep looping all the relationships. Again, if that parent is not a children in any of the relationship, and that will be the main root. So after we find the main root, in this case is the live form, we can start printing off, and we have some spacing in here, and the spacing is dependent on the level, and level 0 has the smallest amount, which is no spacing, and then level 1 have a 1 space, and level 2 has a 2 spaces, and that's how we scale it by times it. And then we can concatenate this line string to the root that we print off. And then this is the main root. That's the root that we are printing. And then we can subsequently recursively call this function. So this is where we use the parent to the children dictionary, and then we look at all the children that belongs to this parent. So for all the children, and then we call this function again. And then whenever we call this again, because it's already the children, the level will be increased by 1, which will increase the spacing. So to trigger this function running, we need to input the main root, which we found earlier. And then the main root has no level, so its level is 0. That's why it has no initial spacing. And when we execute this function, this is the output. Live form has no spacing. The lower level or is the higher level is the animal. Fish, bird, mammal has is the children belongs to the animal. Cat is a child to mammal. Lion is a child to cat. So this is the algorithm. We use the depth first search. In terms of the time complexity, as we can see, we have a couple of for loops in here. The first for loop through all the relationships. So this is O of the big O of a number of relationships. Second for loop is the same. say looping through all the relationships again. So it's a big O of the number of relationships. The third one, we are recursively calling this function print output, and then for each other child, and this is the big O of the number of child. So in terms of the time complexity, it's a big O of n plus big O of n, and then plus big O of number of child. And in terms of space complexity, we need a dictionary parents to children is O of n, and also we need the parents are all the keys, and also we need another dictionary children to parents is O of n as well. So this is so much for this Google phone interview coding problem. I hope you like it. Thank you for watching. See you in the next video. Bye bye.